Hello friends, in today's video we will learn about Thevenin's theorem. Actually what this theorem states and how this theorem is applied we will learn. So first of all we will see the statement of the theorem, what this states. This theorem states that any complex two-terminal network can be replaced by a series circuit consisting of an ideal voltage source that is denoted by Thevenin and a resistance RTH. This resistance is also taken in series. So let this is a complex network having two terminal here A and B. Then we can make an equivalent circuit like this. So voltage source will be having voltage Thevenin and one series resistance R Thevenin will be applied, and then we can solve voltage across this terminal and current etc. So what are the steps we have to apply? These are written here. Steps to get Thevenin equivalent circuit. So these are the steps which you need to follow for applying Thevenin theorem. First, disconnect the load resistor from terminal A and B. As you see terminal A and B in earlier figure, and later we will discuss a question where it will be clear to you. And step 2, with load terminal open, find open circuit voltage. Means because we have already disconnected the load across AB, so now it will be the open terminal and we have to calculate the open circuit voltage that will be called Thevenin across A and B terminal by any kind of known method. Means we will apply any circuit theory or Kirchhoff's law etc. or Ohm's law to calculate the Thevenin. Third step, replace the voltage source by internal resistances. Means in the circuit you will be given some cells or batteries having some internal resistance. So if battery has internal resistance, then these are to be replaced by the resistance only if they are having resistance. Otherwise, if sources are ideal one, then ideal source will be replaced by short circuit. Means simple line you will draw and that battery will be short circuited. Further, now find the equivalent resistance that will be called R Thevenin across the terminal A and B. So this is the third step, and after having known the RTH and VTH, we can draw equivalent circuit. So fourth step or final step is draw the equivalent circuit. So these are the steps for applying the I have written one question here to solve with Thevenin theorem, and steps I have already written so that we can solve it in very less time. Then one question is given here. So there are two battery here 10 volt and 20 volt. There are no internal resistance for these batteries. Two resistances 4 ohm and 1 ohm are here, and across terminal means this can be considered as load resistor 5 ohm. So 5 ohm resistor is across AB. So now we have to apply Thevenin theorem to solve the circuit. Our aim is to find current in 5 ohm resistor. Means we wish to calculate current in 5 ohm resistor. So what will be the current in this branch that we need to solve? First, step 1. Step 1 says remove the load resistor. So here in the circuit, in the next circuit, means we can say figure 2. So in figure 2, this resistor 5 ohm resistor has been removed. Then circuit will be like this only. So now only you can see these are in series. So just one current will be there in the whole circuit, entire circuit. In next step, we have to calculate voltage across AB. Means that will be the Thevenin also. So now our aim is to calculate voltage across AB by any known method. So I am applying here Kirchhoff's voltage law. So as I have already said that it is only series like circuit, means two sources are there and two resistor, and only single current will be circulating in this loop. So therefore we are applying Kirchhoff's law. If I start from this point, then I can write Kirchhoff's voltage law like this, means 20. Then this is 1 ohm resistance, current is I. So because we are passing through a resistor, therefore 1 into I means I. Likewise 4 into I, then minus 10 volt equal to 0. So I am completing the loop from this, starting from this point to this point again. Therefore I can solve value of I. I will be 10 over 5 or 2 ampere. So this is the current in the circuit. Now it is clear that it is the reference point. Both the batteries are connected on this point. So this is the zero potential point. Means voltage at point B is 0, and voltage at A we can calculate if we start from this point, means O. Then if we pass this voltage battery of 20 volt, then this point will be at 20 volt. Thereafter, because current is circulating, therefore there will be voltage drop of 2 volt, means voltage at this point A will be 20 minus I into 1 into I, and I have already solved, that is 2 ampere. So 20 minus 1 into 2, therefore 18 volt. So 18 volt will be the voltage at this point, means VA. Or I can say V Thevenin, means voltage across these 2 points A and B, or either A or B, it will be 18 volts. So it is the now we have already applied 2 steps, step 1 and step 2, and we have solved Thevenin voltage or V Thevenin. Further, I am using step 3. Step 3 says short circuit the batteries and find RTH across A and B. So what I am doing, I have done short circuiting here. Here earlier here was a battery of 20 volt and here was a battery of 10 volt. So I have short circuited both the battery. Now I have shown by a single connecting wire. So therefore my aim is to calculate R Thevenin, resistance across terminal A and B. Across A and B, you can see now this 4 ohm and 1 ohm will be in parallel combination. So on solving this parallel combination, R Thevenin will be 4 multiplied 1 and 4 plus 1. So therefore 4 by 5 is the R Thevenin, or the resistance across A and B. Now our final step, that is draw the equivalent circuit. So having known value of VTH and RTH, I can draw the circuit. That is here. It is a simple series like circuit, and across A and B there is a load resistor of 5 ohm. So V Thevenin is 18 volt, R Thevenin is, I have already solved, 4 over 5 ohm, and load resistance is connected here. But in the question we have to calculate value of I, means the current in the 5 ohm resistor. So this is the equivalent circuit, and now I can calculate I very simply. Because it is a series, both are RTH and RL in series combination, therefore equivalent value, yani R total or R equivalent equals to RTH plus RL. Therefore I can write 4 over 5 plus 5. After solving, you will get 29 over 5. And I can be calculated by I dash. I have taken current I dash here in this loop. So therefore I dash will be V Thevenin over R total. And that would be 18 volt divided by 29 over 5. So it will be 18 into 5, 5 will go upside. So therefore 18 into 5 over 29. On multiplying, you will get 90 over 29 ampere. So this will be the current. So our problem is solved. So I hope this video is very easy and easy to understand, and I think the Thevenin theorem and other and steps of Thevenin theorem will be clear to you. And if you are finding the videos very useful to you, then share, like and subscribe this video. Thank you. Thanks for watching.